Eighth question. This is a very, very easy question. So I am going to solve it at 5 different levels. Yes, 5 different levels. Okay. X of s is the Laplace transform of a signal x of t. Laplace transform of dx by dt, assuming x of 0 is 0, is. We are given 4 options. So what we are given is x of s is the Laplace transform of x of t. We want Laplace transform of the derivative of x of t. Given x of 0 is 0. Okay. At the very, very first level of answering the question, we randomly pick one of these answers, right? That's like inky pinky ponky, and we do, and somehow we end up at say option B. This is a very, very bad approach to answering the question, because in GATE we know there is negative marks. Question is for 1 mark. We have a negative mark of minus 1 by 3. Chance of this being correct is 1 by 4. So very likely we are going to get negative marks, which will also affect our time spent on other problems and marks obtained in other problems. So first level, it's blindly guessing, is really bad. Okay, what is slightly better than this? Slightly better than this is to eliminate some of the wrong options from here. And if we somehow crudely remember that, the things that facts that we picked up during engineering math classes, that Laplace transform somehow transforms differential equations into algebraic equations, right? So when we take Laplace transform of some functions, the derivatives are likely to disappear. So at this stage, instead of blindly guessing, if we have to smartly guess, I would eliminate options C and D, because Laplace transform is supposed to remove derivatives. And now I end up with 2 options. If I have to blindly pick one of them, probability of it being correct is 1 by 2, which is better than minus 1 by 3. We are likely to get positive marks out of this. Okay. But again, random guessing is not a good way to do, especially when you have negative marking. Something that's slightly better than this is answering the question from memory. We know Laplace transform. We know the properties of Laplace transform. One of the first basic properties of Laplace transform is that Laplace transform of a derivative of a function is x times x of s minus x of 0. It's one of the first properties of Laplace transform, basic properties. If you remember it, we can go ahead and pick option A, which is the correct answer, right? And of course, we are also given x of 0 is 0. So option A is the correct answer. But let's say we somehow did not remember all the properties and all that. At this stage, a very good way of answering this question, which should take about a minute or 2, is to use the definition of Laplace transform. Okay, if we don't know the definition of a Laplace transform, we are in a different league. But let's say we know the definition of a Laplace transform, but don't remember its properties. Let's try to find out what this term is. So the first thing, what is the definition of Laplace transform? Is 0 to infinity, we take the original function, we multiply it by e power minus st dt. Okay, so multiply by e power minus st and integrate it over time, so that we end up with this new function x of s, which is a function of this frequency variable we introduce here. Okay, so this is the definition of Laplace transform, and using the definition, what we want is this term is 0 to infinity dx by dt, okay, e power minus st dt. any function times this integral of that, we have dx by dt. So that function times this integral of that. At this stage, we recognize this is not directly of this form, right? So here comes the major trick used in most of mathematics. Given a new problem, make some modifications, make some changes, make some transformations that will help us morph or change the new problem into a known problem. Had this derivative that's over x, if it is not there, we will end up with the Laplace transform that we know, right? Is there any way to remove this derivative from this term x? Is there any trick? Yes. In this case, there is a simple trick, standard trick known as integration by parts. Okay. So integral of u dv is uv within its limits minus b du. Okay. So I am going to call this dv and call this u. Then this becomes uv, which is x times e power minus st from the limit 0 to infinity minus b du, that is 0 to infinity x times du is minus s times e power minus st dt. Integration by parts. Okay. At this stage, we notice there is an integral which is a function of t, right? So x of t times s. So we can take the s outside this integral. Okay. And when minus x goes here, this becomes plus s. Okay. And this term over here, when you substitute the upper limit minus infinity, e power minus infinity is 0. So this becomes 0 minus, when you substitute the lower limit, it's x of 0 times e power minus 0, which is times 1. Agree? So this term over here is minus x of 0 plus x of s times this term. The moment we remove the derivative from the x of t, we realize this is something that we already know. What is it? That is just the Laplace transform. Okay? So what we end up with is, this is minus x of 0 plus s times, this whole thing is known as by definition x of s. So we use the definition and derived what this function is, which we notice if x of 0 is 0, we get option A. Using the definition, we derived this particular property. That's a very good way of answering this question. Okay, should take about a minute or two. Okay, now that we have answered that question, what are other ways of answering this question? Are there more difficult levels at which we can address this question? My answer is yes. Okay. Okay. So we found the answer for the given question, but let's rephrase the question so that we understand Laplace transform better. We practice applying some math strategies, and we also prepare for answering future exam questions, as well as see all of a sudden a new problem shows up during our work. We want to be able to address that, right? So here is a new question. We wanted Laplace transform of the derivative that gave us s times x of s. But now I am going to say the answer is x of s by s. When will that happen? That is, what should have been the question? Okay, what should have been the question? What should have been the function in the integral? Sorry, function in the Laplace transform that would give option B as the answer. Let's go ahead and answer that. One thing we notice is Laplace transform converts derivatives into algebraic expressions, right? So this is Laplace transform of dx by dt, right? It takes derivatives and converts them into algebraic equations. And also notice, when you look at the derivative, we get a multiple of s over here. So we want 1 by s, right? 1 by s. A nice guess at this stage would be to consider integral of x. Okay, so let's try that. Let's say g of t is the integral of x of t over a dummy variable tau from 0 to t. So instead of derivative of x, I am going to look at try the function which is integral of x. At this stage, once I write this function g of t, what do we know about g of t? Couple of things are evident. What is g of 0? G of 0 is integral 0 to 0, that is 0. Okay, integral has nothing, single point, no area in it. Then we also know that one of the fundamental theorems of calculus says that if g of t is the integral of this, what is g dash of t? G dash of t is x of t. So the moment we write this down, we can write these two. Say properties of g of t. G of 0 is this and g dash of t is x of t. How are these two things going to help us? Again, so let's try to find the Laplace transform of g of t. The way we are going to do that is by using known things. We know Laplace transform of x of t. We also have this result on derivatives. Okay, notice derivative of g of t is x of t. Given all this, I am going to try Laplace transform of x of t. Okay, which is x of s. Agree? And this becomes Laplace transform of x of t is Laplace transform of g dash of t. G dash of t. Agree? So what is Laplace transform of a derivative of something? That is s times Laplace transform of g of t minus g of 0. This is from the result that we just obtained. Fine. We know g of 0 is 0 and we have the term that we are trying to find. So this implies Laplace transform of g of t, which is the integral of x, that is x of s. We have a term s here, let's take it to this side, by s. So had the question been what is the Laplace transform of the integral of x, 0 to t x of tau d tau, some dummy variable tau, answer for that is option B. Okay. Now that I raised the possibility of changing versions in order to match the answers, let's go ahead and match. Try to see if option C could be an answer. Option C indeed could be an answer, although I ruled it out initially. Okay. But in order to do that, we have to do a slightly different trick. But again, a very, very simple trick. Which is, we notice x of s, the Laplace transform definition is over here, right? So let's take the derivative of Laplace transform over here. Derivative with respect to s, this is a function of s, we take derivative with respect to s. Okay? So that is derivative of this Laplace transform, okay, which is derivative of this integral. I'm going to weigh my hands a bit, that's fine. I'm going to take the derivative inside the integral. Notice derivative of x with respect to s is 0. This term doesn't affect. Derivative of e power minus st with respect to s, what is that term? That term is minus t times e power minus st. Just derivative of e power ax, where a is minus t. Agree? Okay. At this stage we notice, by definition, this whatever we have here is Laplace transform of minus t times x of t. Because Laplace transform of minus t times x of t is x of t into minus t. To be very clear, this is into minus t. This is a function of x of t into minus t e power minus st dt. Okay. So Laplace transform of minus t times the original function, that is derivative of Laplace transform. So had the question been what is the Laplace transform of minus t times x of t, this would have been the answer. Okay. Again, this is another property of Laplace transform. And finally, let's go to the hardest level, which is a question for you all. Is there any question, any modifications to the question that we can make that would help us get option D as the answer? Please give your answers in the comment section and let me know if you like this video. I'm sure you learned how to answer the original question in different ways. In the process, you learned what a Laplace transform is, how to derive some of the properties of Laplace transform, and also you are prepared to answer Laplace transform based questions either in exams or in your work or at home. With that, good luck, and I'll see you with another video.